In 1973, a wheel loader rolled out of a Michigan factory that weighed as much as a fully loaded Boeing 737's landing gear, 95 tons of steel, rubber, and raw ambition. The Clark Michigan 675 could scoop up 24 cubic yards of material in a single bite, enough to fill a two-car garage with coal in one pass. Only 14 were ever built, yet decades later, a handful still work in quarries and scrapyards, outlasting the company that created them. This isn't a story about engineering failure. It's about a machine so capable that it arrived at exactly the wrong moment in history. When its parent company was hemorrhaging money, the economy was collapsing, and the construction industry was about to face its worst crisis since the Great Depression. The Clark 675 didn't fail. It was simply born into a world that wasn't ready to save it. In 1953, Clark Equipment Company acquired Ross Carrier, a Michigan-based manufacturer building heavy equipment under the Michigan brand since the 1920s. Among contractors and quarry operators, Michigan Equipment had a reputation, machines built by people who understood what it meant to move dirt for a living. Through the 1960s, Clark Michigan's loaders earned respect for durability. Models like the Michigan 175 and 475 became workhorses at construction sites across North America. But by the late 1960s, the industry was changing fast. The interstate highway system was expanding, massive dam projects were underway, and open pit mining was scaling up. Contractors needed machines that could move more material, faster. Caterpillar answered with the 992 in 1968, 60 tons, 525 horsepower, a 10 cubic yard bucket. It became the benchmark for mining class loaders. Clark's management watched and made a decision: build the largest, most powerful wheel loader in production. Don't worry about market size. Build something that makes everything else look small. The target specs were audacious: 20 to 24 cubic yards, more than double the Caterpillar 992, the operating weight approaching 100 tons, and somewhere around 1,200 to 1,600 horsepower, power levels you'd find in locomotives, not rubber-tired construction equipment. The engineering challenges were immediate. A loader that size would generate forces that would tear apart conventional frames. The hydraulics would need to exceed industry standards. The tires would need to support weights no earth-mover tire was designed to handle. Work began in 1969. The machine that emerged would be called the Michigan 675. The first 675 prototype rolled out in 1970, and even standing still, it commanded attention. Over 40 feet long, with the bucket extended. The cab sat 13 feet off the ground. The bucket was massive enough that workers could stand inside it with room to spare. The most distinctive feature was hidden in the rear: two Detroit diesel 16 Vice 71 engines mounted side by side. Each displaced 1,136 cubic inches across 16 cylinders, generating 700 to 800 horsepower. Combined output: 1,400 to 1,600 horsepower. The Detroit diesel 16 Vice 71 was proven technology, a two-stroke diesel known for reliability and a distinctive exhaust scream under load that was unmistakable on any job site. But the dual-engine setup created problems almost immediately. Two engines meant two of everything: cooling systems, fuel systems, exhaust systems. Heat management became a nightmare. Worse, coordinating power between two engines proved difficult. Slight variations in throttle response caused one engine to work harder than the other, creating mechanical stress and uneven wear. The prototype could do everything they had hoped. The bucket capacity exceeded 20 cubic yards. The hydraulics delivered breakout forces that tore through compacted material. Despite its size, the articulated steering provided surprisingly tight turns. But the dual Detroit diesel setup was killing them on reliability and maintenance. Clark's engineers made a critical decision: scrap the Detroit diesels, redesign around dual Cummins engines. Better serviceability, more consistent power delivery. But it pushed production back to 1973. By then, Clark had invested millions. The machine worked. Now they needed to sell it. The production 675 that emerged in 1973 deserved attention. To understand why, you need context. Caterpillar's 992 was the industry benchmark: 60 tons, 525 horsepower, 10 cubic yard bucket. The Clark 675 made it look modest. At 95 tons, it outweighed the Cat by more than 50%. The dual Cummins engines delivered over double the power. The 24 cubic yard bucket moved more than twice the material per pass. But the numbers only told part of the story. The frame used box section construction with cross-bracing designed to handle loads that would twist lesser machines. The articulated steering pivot was engineered with tolerances more common in bridge construction than mobile equipment. The hydraulic system was particularly impressive: a closed center circuit with load-sensing capabilities, advanced technology for the early 1970s. When the operator curled the bucket against heavy material, the system delivered maximum pressure. When moving empty, it reduced flow to save fuel. Skilled operators had extraordinary control despite the machine's size. The first units went to operations where capabilities could be fully utilized. A Midwest coal mine used one to load unit trains. The 675 filled a rail car in 2 passes, where smaller loaders needed 5 or 6. A Southwest copper mine found the 675 could load their 85-ton haul trucks in 4 passes instead of 8 to 10. Loading time cut nearly in half. Operators who ran the 675 consistently said the same things: surprisingly nimble for its size, smooth hydraulic controls, sheer capability unlike anything they'd experienced. One operator described it as driving a building that could lift another building. Under heavy load, both Cummins engines working created a distinctive sound, exhaust notes slightly out of sync, a rumble you could feel in your chest. Clark marketed the 675 as offering the biggest bite on wheels. It was literally true. No production wheel loader could match it. But beneath the engineering excellence, warning signs were accumulating. Sales were slower than projected. The purchase price, several $100,000, was substantially higher than competitors. By late 1973, Clark had built maybe 4 or 5 units. Then, in October 1973, the world changed in ways that would doom not just the 675, but threaten Clark Equipment's entire existence. On October 17, 1973, OPEC announced an oil embargo against nations supporting Israel in the Yom Kippur War. Within weeks, crude oil prices quadrupled, from roughly $3 per barrel to nearly $12. Gas stations displayed no gas signs. Fuel rationing began. Industries dependent on diesel went into immediate crisis. The timing couldn't have been worse for the 675. The dual Cummins engines consumed diesel at rates approaching 40 to 50 gallons per hour under load, roughly 4 times what a standard loader burned. At pre-embargo prices around 35 cents per gallon, operating costs were high but manageable. When diesel hit $1 to $1.20 per gallon, the 675's fuel consumption became economically devastating. Mining companies considering 675 purchases suspended acquisitions. Operations already running units began calculating whether productivity gains justified fuel costs that had tripled overnight. Some seriously considered parking their 675s and returning to multiple smaller loaders. But the oil crisis was only the beginning. The broader economy collapsed into recession. Construction spending plummeted. Mining operations cut production. Equipment sales across the entire industry cratered. Caterpillar's sales dropped sharply. International Harvester posted major losses. Smaller companies disappeared entirely. And Clark Equipment, already struggling with the expensive 675 development program, found itself fighting for survival. Clark's troubles extended beyond the 675. The company had pursued aggressive acquisitions through the 1960s: Melro, maker of Bobcat loaders, refrigeration equipment, food service. Diversification was supposed to insulate them from any single industry downturn. Instead, when recession hit, Clark was exposed to collapsing demand across multiple sectors simultaneously. The 675 program became an obvious target. Millions invested in development. 14 units built by 1976. Sales essentially stopped. The math was brutal. Massive investment, 14 units sold, ongoing support costs for a machine that would likely never see additional sales. From a pure business perspective, the 675 was indefensible. Production ceased in 1976. Clark made no formal announcement. In the chaos of mid-1970s recession, discontinuing one product line barely registered as news. But Clark's troubles weren't over. In 1982, the company sold its entire wheel loader and dozer division to Volvo. The sale was driven by necessity. Clark needed cash, and construction equipment wasn't generating adequate returns. The Volvo acquisition meant the Michigan brand would be absorbed. The 675, already out of production for 6 years, became a footnote. The 14 units were on their own, supported by parts inventory that would gradually deplete, maintained by operators who'd have to source components wherever they could find them. 2 units were later bought back by Clark, rebuilt, and resold as 675C models. Including these rebuilds, 16 675 designated machines existed, but only 14 were original production units. By the mid-1980s, most 675s were still in service, working at mines and quarries where their capabilities justified the maintenance challenges. But the machines were increasingly orphans, products of a company that no longer existed in the form that created them. The 675 story seemed over. By the mid-1980s, tracking the 14 original 675s was like searching for rare artifacts. Most had changed hands at least once. Some had moved to different industries entirely, but they kept working, and that durability became the 675's real legacy. A Pennsylvania quarry operated their 675 for over 15 years, loading crushed stone for highway construction, thousands of hours, multiple tire replacements, periodic hydraulic rebuilds. But that massively over-engineered frame, those hydraulic cylinders built to withstand forces beyond normal operation, proved nearly indestructible. When the quarry finally sold the 675 in the late 1990s, it went to a scrap yard that needed a loader for heavy steel bundles. The machine transitioned from stone to scrap metal and performed that role for another decade. A machine supposed to be obsolete was still working profitably 25 years after it was built. A West Virginia coal mine ran their 675 until operations scaled back in the 1990s. Sold to a construction company, then to another mining operation, accumulating owners but continuing to work. Each new operator discovered the same truth. Keep it fueled, maintain the hydraulics, and the 675 would outlast anything else on site. The maintenance challenges proved manageable with experience. Operators learned to anticipate parts needs. Wear items, hoses, filters, seals, could be sourced by matching specifications rather than ordering Clark-specific parts. The dual Cummins engines, while fuel-hungry, were mechanically robust and could be serviced by any competent diesel mechanic. One of the most remarkable survivor stories. A 675 purchased by a mining operation, sold to a quarry, sold again to a scrapyard where it loaded rail cars. That machine was still operating in the 2000s, over 40 years after it was built, performing the same basic function it was designed for. While Clark Equipment no longer existed as an independent company, sold to Ingersoll Rand in 1995, then to Doosan in 2007, the 675s outlasted the corporation that created them. Machines built during Gerald Ford's presidency were still working during Barack Obama's. Meanwhile, the wheel loader industry had caught up to where the 675 had been in 1973. Caterpillar introduced the 994 in the early 1990s. Over 200 tons, bucket capacity exceeding 25 cubic yards. Komatsu followed with the WA 1200. These were commercially successful machines that validated everything the 675 had proven. There was indeed a market for ultra-large wheel loaders. The difference wasn't engineering. The 675's design had been sound. The difference was timing and corporate stability. Caterpillar and Komatsu introduced their giants during economic growth, with strong balance sheets and global service networks. The 675 arrived during economic collapse, built by a company already struggling that would soon sell off the division entirely. In 2008, an engineering intern at Caterpillar's Decatur, Illinois plant encountered something unexpected during a factory tour. Tucked in a corner of a storage building sat a heavily weathered Clark, Michigan 675, one of the original 14, purchased years earlier as a competitive teardown. a common industry practice where manufacturers buy competitors' equipment, disassemble it, and study the engineering. The intern asked why Caterpillar had bothered studying a machine from a company that no longer existed, built in numbers too small to matter commercially. The senior engineer paused. Because they got a lot of things right, and we wanted to understand what we could have done better. That captures the 675's place in history. It wasn't a failure in any technical sense. The machines worked. They delivered the productivity gains Clark promised. The engineering was sound, in some ways ahead of what competitors were doing. But commercial success requires more than good engineering. It requires market timing, corporate financial stability, and luck. The 675 had none of those advantages. What if Clark had introduced the 675 in 1977 instead of 1973? The oil embargo would have passed, the recession ended. The machine's fuel consumption wouldn't have hit the market during an energy crisis. Clark might have had time to establish proper service support before economic pressures forced the division's sale. Today, mining operations specify Caterpillar 994s, Komatsu WA120s, Liebherr L586s, machines supported by global service networks. They represent the market the 675 tried to create but couldn't sustain. The Clark, Michigan 675 was too powerful for its own time, not because the world wasn't ready for ultra-large loaders, but because the machine arrived at a moment when everything conspired against it. Wrong economy, wrong energy crisis, wrong corporate circumstances. But the engineering was right. And somewhere in those Caterpillar files, there are probably notes about frame construction and hydraulic designs that a small Michigan manufacturer figured out in 1973. Good engineering doesn't stop being good just because the market isn't ready. Next time you see footage of massive mining operations with wheel loaders filling 400-ton haul trucks, remember that someone tried to build that capability 50 years ago. They succeeded technically and failed commercially, but a handful of their machines outlasted the company that built them, and the competitors that dismissed them. The Clark, Michigan 675 wasn't a magnificent failure. It was a magnificent machine that arrived at the worst possible moment. If you've ever operated a 675, worked on one, or seen one in person, share your story below. These machines are rare enough that every encounter is worth documenting. History shouldn't forget the engineers who built something too powerful for its own time, or the machines that refused to quit.